Reflection. Light travels in wave fronts. We represent the direction of motion of light by constructing perpendicular lines to the wavefronts and calling them light rays. Geometric optics studies the behavior of light rays as they reflect off mirrors and refract through lenses. So here's our wavefronts. The lines represent the crests, so there's troughs in between the lines like this. And that's how the waves propagate this way. So a ray is going to be a perpendicular line that's showing the direction of the wavefronts. Here we have plane wave, and the light rays would still just be pointing in the direction of propagation. You can see a pencil on a desk from any angle, as long as there's nothing in your way. Light rays from the overhead light reflect off the pencil in all directions, as shown, and some of those light rays end up at your eyeball. If you are in a pitch black room, you can't see anything because no light rays are bouncing off of objects and ending up at your eyeball. The law of reflection states that the angle of incidence is equal to the angle of reflection. All angles in geometric optics are measured from the line normal to the surface. So here's our surface, here's our normal line that's perpendicular to the surface, and we're always going to measure our angles to the normal, not this angle here. When light bounces off of perfectly smooth surfaces, it is known as specular reflection. Examples would be light reflecting off of shiny metals and mirrors. Most of the problems we will see in this course will be specular reflection, where we're dealing with just perfect mirrors. When light hits a rough surface and reflects, the law of reflection still holds true for each light ray, but the angle of incidence varies at different parts of the surface, shown here. So the light is diffused. Enough of the rays still enter your eyes so you can see the object. We see most objects by diffuse reflection. Most objects are not perfect mirrors. When you look into a plane mirror, also known as just a regular flat mirror, you see an image of an object which appears to be inside the mirror. This is called a virtual image, since the light rays that meet your eye are not actually coming from the object. The light rays look like they're coming from inside the mirror. In the John Tenniel original illustrations from Through the Looking Glass and What Alice Found There, written by Lewis Carroll, Alice first sees her virtual image, which appears to be inside the mirror. Unlike reality, she then passes through the mirror, replacing her virtual image with her real person. Human eyes did not evolve to understand mirrors. When you see an image in a mirror, your brain thinks that that is where the object really is. Your brain assumes that the light rays reaching your eyeballs must have originated inside the mirror. The human brain assumes all light travels in straight, uninterrupted paths. So while the real light rays are actually coming off the object, bouncing off the mirror and hitting your eyes, your brain thinks there's actually an object here and the light rays are bouncing off of it right into your eyes. When you look into a mirror, you see an image which appears to be behind the mirror, also called the dark side of the mirror. The distance from the object located on the light side, the real object, to the mirror, S sub O for object, is the same as the distance from the mirror to the image, S sub I. A virtual image is formed by extending the light rays to a place where they converge on the dark side. That image cannot be projected or focused on a screen. It is not a real image. An observer can only see the image of an object in the mirror if the light ray from the object strikes the mirror at an angle, theta I, incident angle, that results in a light ray bouncing off with theta R for reflection, and that light ray can make it to the person's eyeball. Also, a line connecting the image to the observer is going to pass right through the mirror like this. When you see these little lines like this is representing the back side of the mirror. All right, let's analyze. We have two people, A and B, and we have one real object here. An observer at point A will be able to see the reflection of this jug in this mirror, because there is a line that of a light ray hitting the mirror, bouncing off with an equal angle, and ending up in your eye. However, at point B, there is no light ray that's going to be able to bounce off the mirror and end up at person B's eyeball. There is no possible reflected light that can reach observer B's eyes that originate from this object. The other type of image is a real image. A real image is formed at the point of converging light rays on the light side. The light rays actually pass through that point, and they can be projected and focused on a screen. A real image is not formed by a plane mirror, but is formed by spherical mirrors and lenses in certain situations, as we'll find out shortly.